Hello everyone, this is Ryan Miles, Solutions Engineer with Cisco, and I'm here today to talk about the MG Cellular Gateway and Wired WAN mode. Wired WAN mode allows for a pass-through mechanism for the MG Cellular Gateway. And in this simple diagram, I have a MX security appliance with a ISP connected to the WAN 1 port, and then I have a second wired ISP that is connected to the MX WAN 2 port, but it passes through an MG that's been configured for wired WAN mode. So what that means is WAN 2 on the MX physically is connected up through the MG, but just simply passes from port 2 to port 1 to reach wired WAN ISP2. And the way this flows from a failover perspective is, in this case, WAN 1 is configured as my primary WAN link. You could, of course, be load balancing across those LAN links, but for simplicity's sake, we'll just say that we're using the default mechanism with WAN 1 being the primary. And if that fails, the MX will now start to use the WAN 2 port, but it is flowing or just passing through the MG to wired ISP number 2. If that WAN connection fails, then the MG using the wired WAN mode will fail over to its cellular connection. So in this case, I have three-way carrier resiliency while just using 2 physical ports of the MX. This is a much more complex solution, but something I have labbed up just to show how it all works out. This basically allows for 4 providers on an MX with 3 wired WAN ports. And in this case, I'm using the feature called backup WAN link on the MX, and that in which I can use WAN 1, WAN 2, and physical port 4 as a third WAN connection for backup purposes. So in this case, my Comcast connection is connected to wired or WAN 1 on the MX, and that's my primary circuit. And then WAN 2 on this red link connects down through my switch on a breakout VLAN, which then goes to a further downstream switch out to an MG with a SIM on the Verizon network. And then last, my WAN 3 port with this orange line is connected down through my switching fabric, again to a breakout VLAN, which connects over to the MG on the far right. That MG is using, again, that wired WAN mode, so it actually is just flowing through over to the MG in the middle here and using its cellular connection. I'm powering all of the MGs, as indicated here, from my switching layer. And in the case of the MG in the middle, because I want it to be cellular only, I am powering it through port number 2 on my switch, and I just have that assigned as a null VLAN 666, just a dead VLAN, simply to give it power, but no data path, forcing it to use the cellular pathway. So from a failover perspective, what it looks like is, like I said, WAN 1 is my primary. If that were to fail, then now the MX is using the WAN 2 connection down through the switching fabric. These green lines are simply .1Q trunks carrying all VLANs. So I will come down to my switching fabric and pass out or flow out through my Verizon MG on the lower left. If that connection fails, then I will start using the third WAN link on my MX, which flows through my switching fabric, comes all the way down to my wired WAN pass-through mode MG, and ultimately goes out my MG52 over here in the middle. And if lastly that one dies, this MG on the far right, running in wired WAN mode, will sense that it no longer has a wired WAN pathway that is valid, and it will fail over to using its cellular connection. This is a pretty complex topology here, maybe a little bit out of the usual, but something I wanted to validate in showing 4-way carrier redundancy. And then lastly, while I performed all those failover processes shown in the previous slide, I ran a continuous ping, as well as I was refreshing a what's my IP site, showing that in each of the cases of failure, I would fail from my Comcast IP to my Verizon IP to my first primary AT&T IP, and then all the way to my last and final fourth IP through the sole remaining MG. And in each of the cases of failover, from WAN 1 to 2 to 3, and then through the MGs, as you can see here, I was only losing usually 2 to 3 pings at maximum. Hope that was helpful, and thanks for watching.